Okay, in this lecture, we're going to talk about reduction, Earth engine data reduction. It can be useful if you need to, for example, reduce an image collection, so a bunch of images into one image, or if you want to calculate some statistics based on a column of feature collection. So basically, think about reduction is to reduce either the dimension or the size of the data, and we want to get started with just the list reduction. So the simplest one. And here, this example shows you, for example, a list of sequence with numbers 1 from 10, right? So this is the list. List it has a number of elements. And what we can do is to reduce this list of numbers into some specific number. They say if you want to calculate the count, okay? So what you can do in most of the Earth Engine object, for example, image collection, feature collection, or list has a reduce method. If you go to the Earth Engine documentation, go to references and client libraries. So for example, here, if you look at e-doc-list, look at the e-doc-list. So it has a number of elements. Most of those has a reduce function. So if you click reduce here, so the reduce function, you can pass in a reducer. A reducer can be one of the example from the reducer. So e-doc reducer. And you can see we have some of those in here: first, last, combine, count, minimum, maximum, something like that. So you can think about for example, you try to do some simple statistics of the data set. So what we are doing in here is that you have a list, and then you are calling the reduce function. Inside the reducer function, you can pass in a reducer. So the e-doc reducer dot count is you're trying to figure out how many elements in the list. So it can be a feature collection. You can figure out how many images in the collection. And this is pretty simple, but so it's going to give you just one number. So take a look at this one, right? So we have a list of 10 elements, reduce, and then you passing the count is going to show you the 10 counts. This might seem very simple, but that's not the point, because most of the time you cannot just visually look at how many in there. You need to depend what you're going to do depends on how many of the elements. So it varies, but this one at least give you the number of elements. You can also use the doc size. This has the similar effects. So values doc. I'm not sure if this one has the size or not. Doc size dot get info. Okay, also it's 10. So just it's the same idea here, but e-doc reducer is like more general. You can pass in anything. Similarly, you can do a mean, right? Get the minimum value. So e-doc reduce dot mean is that you passing this reducer and then trying to figure out what's the mean value of this list, right? Of course, from 1 to 10, you can tell it's 1, but that's not the point. The point is that you use the computer to figure it out automatically. So you can calculate the mean, max. If you want to min max together all at once, you can use e reducer the min max. Okay, so again, any function in here, most likely you can apply to the list. So you're going to show you a dictionary. The dictionary has the key min 1, max 10, right? You can also calculate the average. So the mean e reducer the mean, and then the same, right? So most of the same idea. You can also calculate the median. So if you're giving a list of numbers, you want to calculate the median. This can help you as well. And we can calculate the sum, standard deviation. I believe you can also calculate the statistics. So if you go to somewhere, does it have the statistics? Yes. I remember it has the statistics. If not, that's fine. You can for some images, I think we can calculate the statistics. Anyway, so this basically shows you how to do the reduction. So it's a very important concept in Google Engine, because sometimes you are dealing with a lot of images. You just want to reduce the size, the dimension, reduce the time series. Think about you have like temperature every day, right? For a specific location or for the entire US or for the globe. And you're trying to calculate the maximum temperature throughout the year, right? You're trying to figure out when what has the highest temperature, or what is the highest temperature throughout the year for a specific location, then you need to use reduction. Be essentially you're taking a time series of images, or a time series, or a feature collection. You want to reduce to one, right? So from three-dimensional to two-dimensional, or sometimes from two-dimensional to get a number. So for example, I give you a DM, and I'm asking you to calculate the maximum value of the highest elevation in your area, right? So that means you're getting a number out of a two-dimensional continuous image. So that's also part of the reduction. So the next example I'm going to show you is to how to do the reduction from image collection. So we are going to create a map, and then we're going to use the Landsat 8 top of atmosphere image collection, and we're going to filter by 2021, and this is the pass and roll. So basically using the WRS reference system, so we know exactly what's the location. So basically giving a point, I want the data for the 2021 using this Landsat 8 data. So of course you're going to get a bunch of images for that location, and then we're going to apply the reduce function. So the reduce, and then we take this one, e.reducer.median. So what we are doing here is you take all the images, each image has multiple bands. I'm going to apply a median reducer. So basically you are taking the median, each pixel, you're taking the median value of among all the images, and after that, let's take a look. So this is more like in general, you can take a look at this one here. It looks pretty good. There are not a lot of cloud, but this can have a lot of images. So if you want to figure out how many images in there, you can look at the collection doc size. You can figure out, whoops, it's supposed to print out the number. Why? I'm not sure why it's not showing. So there might be something a bug in the recent OS engine API. Anyway, so basically in 2022, there are, in this specific area, there are 22 Landsat 8 images for 2022. So because it has 16-day reflective frequency, so it's kind of a more than 12, but it's less than 24, right? So almost like double. So we have 22 images, but the outcome here is only one image. So if you take a look at this thing here, only has one image. So what this one is doing is taking all the images together and then compute the median, and then with that median, now we have this final outcome. So this is so-called the reduction, reducing a time series into image. So you're welcome to adjust this. Basically, you can take any images and then you apply the reduce. Although you can do this one here, but you can also do like a shortcut. So the shortcut, let me see here. But I think I need to change this one here. So you can take the shortcut is just median, MEDIN. So this one under the hood is calling the reduce and then passing the reducer function. But if you're directly using this one, the file name, the bank name will be the same as the original image, right? So if you look at the original image, collection doc first, doc get info. So it's going to get the first image. So you see the bank name is B1, B2, B3, B4, something like that. So I'm going to just showing you. So if you're trying to do this, then basically when you're using a reducer, it will add underscore the name of the reducer, whether it's mean, median, is going to add to that. But if you directly use the median function, then the final outcome, the bank name will still be the same as the previous one. So you need to remove this so that you can visualize the bank. So if I run this one again, you should see the same result, right? So take a look at this. Pretty good. So this is basically the two ways. You can already directly use collection doc min, collection doc max, or collection doc min. You will be able to calculate that. Under the hood is calling the reducer function. So the same idea. So this one shows you, for example, right now it's B1, B2, all the way to all the bands. So this is taking a time series and it's going to apply for all the bands. So you end up with one image with the same number of spectral bands as any of the images in the image collection. Similarly, you can also do a image reduction to one image, right? So you're taking a time series into one image, or we can take one images with multiple bands into one band. So what this example showing you here, let me run example first. So we're creating a map, and then we are getting this lane set image. And then we select B4, B3, B2. So basically red, green, and blue band. So we have 3 band, and then we are going to apply a reduce function methods to these 3 bands. So basically RGB, and it's going to reduce the max. So what this one is doing is taking the RGB image, and then for each pixel, I'm going to pick out the maximum value among these RGB 3 channels. So sometimes you might get the maximum value is in the R channel, the red channel, green channel, blue channel, whatever, and it's going to take one. So the result will be just one band. So there's no multi-band anymore. So if you click here, for example, open this one and maybe inspect, right? So right now you see the maximum value here, original value, original image, right? So this one is original one, has RGB, and this one is the final maximum. So if you click anywhere, right? So B2, B3, B4, the maximum will be 8,708, right? So reducing a number of bands to one band, or reducing a number of images to one image. But that one image has multiple bands, so just want you to be aware. So that's for image collection, and the next one is feature collection reductions. So feature collection reduction means you can calculate the statistics of a specific column. Previously, in the previous lecture, we did cover how to use the aggregate sum, aggregate mean, something like that. But you can also use the reduce column and then passing a reducer. So let's take a look at this example. So we are using the census block, and we're going to try to find a specific area. So for this specific county here, the census county data, and what we are trying to do here is to calculate, for example, the total. And what we can do is, depending on what column you want to calculate. So let me use the inspector here and inspect that. So here shows you all the columns for this feature collection. And we might be interested in, for example, the housing and also the population. Okay, that one's 0. Let me try another one here. Just to show you, right? It's still 0. Interesting. Let me try something here. Oh, now this one has something. Okay. So the population for the housing, for example, how many houses, and the population, okay, 37. So that means in this census block, it has 37 people, it has 14 houses. So for all the census block, we're going to have like population and also houses. How about if you want to calculate like all the populations, total populations? So can you think about this is a shape file, and you open the attribute table and select the column. You're trying to calculate the sum for the population 10 column and also the housing 10 column. So basically you're calculating the value of those 2 columns. So what we can do here is take a look at this one. So sum equals to band.filter. And what we're trying to do here is e.filter not none, because sometimes if there's no value, and some of the columns you might have to exclude it. So this one is basically we're doing the filtering again. So all the census block data, and we're going to select those that do not have none values. So basically means at least it has some values. And then we apply this reduce column. Again, reduce columns. Think about you have multiple columns and you want to reduce the column to a number, right? So here, reduce columns, and inside here, we have 2 stars, basically unwrap the dictionary. So into passing a reducer, e.reduce the sum. So what this one is doing is, okay, I want to calculate the sum for this column. And because we have multiple columns, you need to do this one repeat 2. Okay, so this one is a bit difficult to understand, right? You can follow the same format. What we are doing is that, okay, select these 2 columns and then apply a reducer to these 2 columns, to each column, because you're doing that twice. So you need to use the repeat 2. And in that way, you want to get the result. You need to use .get info. I think you need to update to the latest version. Then you don't need to type the .get info. Not sure why right now it needs to do that. But anyway, so this shows you, for example, 85,579 population, and the housing would be 36,025 245 houses, right? So this is one way you can get the aggregation, make the result. But the shortcut will be here, Benton.aggregate sum, and then passing the name of the column. And you can do that again for the housing, right? So if you print out, it's interesting. You should get the result. So anyway, I can just pass in the get info function. Try it out on computer. I think I just need to update maybe to the latest version. Then you don't need to type the get info function. Okay, so basically this code block, it get the same result as this one. Okay, so this one is using the reducer, but here we're using the aggregate sum. But under the hood, the aggregate sum is also calling the reducer function, right? Same idea. So I can also use the aggregate stats. Okay, aggregate statistics. This one gave you all the common statistics for the entire column. So think about we have like not sure how many rows, but you can figure out the size. So for example, how many census blocks? So I can just do Benton.size. So get info, right? So you can get how many 2,979. So within those 2,979 census blocks, and you have the population column. So this aggregate those almost 3,100 rows of values, and it's going to show you the minimum. So the maximum population in a census block in this county is 909. Minimum is 0, and you can see how many total count, value count, the weighted sum, standard deviation, something like that. So kind of similar. You open an Excel spreadsheet and you grab the value of a column, and then you try to do some statistics of the column. So this can be useful if you need to reduce to get some results, some statistics, mean, maximum, minimum, count, something like that for your data. Okay, so just to recap, you can do the reduction for an image. So if you're taking an image, then you're going to reduce all the bands into just one band. If you're giving an image collection time series, is going to reduce that into one image with the same number of bands as the original image. Or if you're doing that for the feature collection, so you're going to reduce, for example, the column into a value or a statistics or dictionary. But you can think about basically reduce the size, the data size, to something more meaningful rather than the original number. Okay, and so next about image descriptive statistics. So what this one can be useful is, for example, giving you an image. Sometimes you might want to get all the properties, right? So in the past, I show you we can just use the get info to get all the properties. So we can also use the property name get info. This is annoying. I need to update the package. So shows you, for example, the property name show you all the list of the properties, but it doesn't show you the value. So if you want to get the value, you need to, for example, image get, right? So any image get, the get is to get the property. So if you look at this one, it has the cloud cover. It doesn't show you the value, but you can get the value here, and then get info. You should be able to see the value. So this would be, for example, 0.05, 5%. So this image has cloud cover of 5%. And Gmail has this function that can help you get all the property all at once. Again, this is a dictionary, so I'm also just doing to get info. And you should be able to see the name, the property, and also the value. So the property name, the property value, so you can see all the stuff all in once. So this is called image prop function. You can also have another one, image stats. So this one shows you if you want to easily figure out, for example, what's the maximum value of a band, right? So you can calculate maximum, mean, average, minimum, standard deviation, sum. So because we have multi-spectral bands, so for each band, the maximum value, for example, for B1, for the entire B1, right? For example, for the red band or green band or blue band, this is the maximum value, maximum value, maximum value, right? So this basically think about you're taking a band, a single band, and then reduce into a number, right? So you can calculate, for example, give you an elevation image. and I ask you to calculate the highest elevation within this image. Then you can use this one image stats to quickly get the minimum value, the maximum value, the mean value, something like that. So it's pretty straightforward. You can also get the average, the mean, and this might be useful if you need to do something like this. Okay, so that's about the descriptive statistics. We already covered the zonal statistics in the previous lecture, and also zonal statistics by group. And there's another one here, zonal statistics with two images. Sometimes, because for the zonal statistics, traditionally we are using oh, I think this is the reason is because I'm using older version. So let me quickly update my uh, package so that I don't need to type token info. So what I can do is to conda activate GE, and then I can just pip install SU gmap. It's update to the latest one, or you can use Mamba. Somehow yeah, the 0.25, so it's much older version. So let me restart kernel, run this one, and then I can show you again. And so zonal statistics with two images. Okay, so run it. I hope it works. Interesting. Image visualize. Something is missing. I think kind of a break in the reason. And again, restart kernel. We have been making a lot of changes to the package, so some of the latest improvement might break some of the existing ones. So here, let me run again. Palette. If not, you can always pass in a list of numbers. Colors. Oh, it should not. So let me try something else. Let me go to the book, and I can just grab my example. I need to double check the package, but I can show you data, and then maybe Earth engine images. Let me grab the DM. So for example, here we can do something like this. Okay, so grab this one. Work. So this is directly passing a list of values, right? And with this, now we can do some statistics. So what we're trying to do here is that I'm also going to load the NLCD, National Land Cover Database. So, and with that, right now we have two data layers. We have the DM, we also have the land cover. So what we are trying to do here is that, okay, I want to calculate the statistics of every land cover type, right? So we have multiple land cover type in here, and we also have the DM. We want to calculate the, for example, the mean elevation of each land cover type. So for example, for open water, for vegetation, for forest, I want to calculate the mean elevation with each land cover type. So for example, here we have this agriculture, all the brown color. I want to calculate the mean elevation. So in this case, we are taking two images, right? So we're taking the land cover image, and we also taking the elevation band, and we are not doing vector data. In this case, we need to use the image stats by zone. So what we are applying here, we give you a DM, give you a land cover. So both of these are raster, image, also any image. And then you specify the reduce you want. You can calculate the mean, max, minimum, maximum, something like that. So run this one. Image state by, I'm not sure if there's something break, or if the package, this package problem recently. To CSV. Let me try again. Say emap doc. Image state by zone. Yeah, it should be available, so I'm not sure why it stopped now. Map. Yeah, it's here, so something is going on with the source code. Yeah, it should be available in the commons module. Let me double check the image please. Yeah, okay, this one is very old, so it's point 13.1. Not sure why something is weird. So let me see if we can update here. I'm going to run, for example, oh, I might be starting in the diff wrong map. So this one should solve the issue. It's just the package was way too old. Not sure why it is doing this. So let me update this one, and then we can rerun it. You should be able to see it. So image state by zone basically allows you to easily combine two images as one. Not do some statistics based on two images. Okay, so uninstall, and then right now what's the Gmap version? Okay, 28.1, so it's work now. Let me restart the kernel. Then we need to reinitialize and go back to here. Image stage by zone. Two image. Okay, so we're gonna do it the same. Oh, yeah. That means I need to fix the installation. So sometimes use a Mamba, use pip, so it kind of messed up, and I'm not sure if I'm running out of time, but this is the conda ge. Let me see if I have other packages. Conda this. Yeah, it probably is messed up. So let me see here. Mamba install this c conda was gmap. Or sometimes if something is not working properly, I just remove the entire environment and then just reinstall everything. So hopefully this should resolve the issue. It's very common. We were doing programming. This is going to come up from time to time. So try to be consistent when you're installing the packages. And if you use Mamba, try to use Mamba if the package is available. So let's wait for this one to finish. So hopefully we can resolve the issue. Otherwise, you can also try on Google Colab. That one should on the Linux operating system, so it has been tested to run, should work pretty well. I'm not sure why. Okay, this is weird. So it says already package already installed. I'm going to maybe I think it's a ipylib program. So I'm gonna pip and install ipylib, and I'm also going to pip. Oops. Yes, and then pip and install gemap. Okay, and yes, then I'm going to install gmap. So hopefully it should resolve the issue. If not, I will need to remove the entire conda environment and just reinstall. I'm pretty sure it can be resolved. So wait for a couple seconds, and then it should be ready to go, and I can show you again. And I really had no idea why like gmap version was that old when I installed the version. Come on, all packages already installed. Anyway, I'll fix it in next week. So maybe something is wrong with this. I just remove everything and then just recreate it should resolve the issue. You can try it on a computer. If you run into issue, let me know. So hopefully this lecture is useful. If you need to do some reduction on the data, or you want to do some statistics with two images. Mm. We don't have a lab assignment for this week, so you can relax. I'll see you next Friday. Okay? Take care. Bye bye.